Okay.
Looks good to me. I can see everything. How about you guys?
Looks good.
All right. Let's
Cool.
get rolling.
Thanks. Okay. So yeah, I'm going to be talking about readability for a while because that's kind of the intent of this talk, but it comes from a chat that I had with a VP of engineering at Pivotal related to some of the less common guidelines that we have in Go, typically in the code review comments section, but also sometimes in effective Go and some of the proverbs. But anyway, this is me. Call me Sam. I am a senior engineer at a stealth AI startup that I can't talk a whole lot about right now. But if you contact me privately, or if things aren't being recorded, I can probably say more about it. I was at DigitalOcean up until January of this year. And before that, I was at Pivotal working on Cloud Foundry on the log aggregation subsystem. These are some of the projects that I am responsible for, and I've been mainly writing Go since 2013. That was when I had my first professional project. I had been playing with it previously, but anyway, so we're going to start with an obligatory definition slide because, of course, we are. I just pulled this from Google's, define thing. Readability is the quality of being legible or decipherable. Clearly, we're on computers, so we don't really need to worry about legibility. If we do, someone has bad fonts. So we're going to focus on decipherability. Yeah, just a quick note about why we care here. Coming from Python, code is read far more often than it's written. This is just with any long-term project that's going to be maintained over time, you're going to be reading it, and new people who join the project are going to be reading it much, much, much more often than you're originally writing the code or editing the code. The readable code is much easier to onboard people, and also offboarding. If you leave your job, you don't have to spend as much time doing a knowledge transfer. Locating bugs is quicker and easier, obviously. If you can read your code and understand what's happening, then it's a little bit easier to figure out why something is going wrong when it goes wrong. And something always goes wrong. And it's also easier to prove correctness. That kind of goes along with locating bugs, but more along the lines of preventing bugs, I suppose. Just a minor note here, I've always felt doing something complicated in software is super fun. I love writing stuff with unsafe pointers and atomics, but making it look boring is an art form. I like being able to come up with an in-memory database using a ring buffer of unsafe pointers and making it look utterly simple is one of the things that I've done that I'm more proud of in my career. So for deciphering code, because going back to that definition, we're going to talk about deciphering mostly. I kind of see deciphering code as two different things. First, we have the intent. We need to decipher what it was intended to do. Ruby and Perl are very good at this. We can write basically gibberish if we really want to, and it'll do something. But that means that we can also make something interesting happen when normal English sentences are written. Reality is the other kind of side of this that we usually see. What's actually going to happen when we run some code. And for this, like the obvious things are C and assembly, right? They're very close to machine code. So if you can figure out what the intent was, then you can probably figure out what the machine code is easily. But I feel like a lot of our definitions of readability in Go tend to lean closer to this than to the intent. But this was just to point out there isn't one definition of readability in software. So I just kind of want to introduce what I think we probably care a little bit more about in Go, which is predictability, being able to predict how code is implemented, how we might use a library, and what will happen when we execute some code. And you see this a bit in other languages too, but I think that we focus on it almost to the exclusion of all else. So some of the qualities that we look for in Go code that I think lend themselves to predictability is we always try to use clear and concise package and variable names. Like our code shouldn't just be obvious and clear in its intent. It should also be concise, because we tend to believe that readability is hindered with longer names. We tend to avoid else statements. This is something that took me a long time to get used to. Back in my Python days, I hated when someone would return in an else statement, because I would always miss it and think it was kind of an implicit else, or when people would return in if statements, I mean. And I see this a lot when I'm trying to train people in on Go that are coming from Java, Python, Ruby. It's just, we tend to return early, and that seems weird for other languages. And then we also have some weird rules around interface types and implementation, which I'll dig into a little bit. I've provided these links mostly for when we send out the slides. This is where a lot of what this talk is based on comes from. And I've brought in a few of those here that might be a little bit weird. Errors or values. This is something that always comes up when I'm training someone in on Go. They always ask how exceptions work, and we have to go through the whole panic talk and how you should never panic, even though it's there. And how you could kind of fake out exception handling using recover if you really feel the need to, but that probably never will. Little copying is better than a little dependency is another thing that I find really hard to get people to accept. We are perfectly okay copying in a function or something if it means that we don't have to depend on a whole library just to provide us with that one function. It's neither idiomatic nor necessary to put get in the getter's name. I like this one a lot, and it kind of comes from reducing that stutter, and just because we know that we're calling a function, we don't need the verb in the name. When an if statement doesn't flow into the next statement, the unnecessary else is omitted. I just mentioned that. I find that one probably the hardest to get people to accept. Interfaces with one or two methods are common. not everyone is coming from a language that has interface types, but usually when they do, they come from a language that has interfaces as like the source of truth for what something can do, rather than as a sort of local scope of what you need something to do. The further from its declaration that a name is used, the more descriptive it must be. The inverse is also true. Getting people to use single letter variables seems difficult sometimes. And this is, yeah, just when you're teaching someone else Go, at least in my experience, there aren't a whole lot of people who are just on board with rules like this. We're just going to kind of go through some examples in case people are unfamiliar with them. This is something that we probably still see in a lot of Go code, where you have a constructor and then someone decided that there needed to be a new argument, and so they created a new constructor, and then there end up being like 10 different constructors to do things in slightly different ways, and they all have incredibly long names. So just a few questions here I'm running through. Does the long package name add clarity? Is it useful to have user service in the constructor names? And the long parameter names also, like, yes, they are giving us more information about what that parameter is. But in the Go world, we kind of say that each additional few characters is causing us to need to do something like, for example, scroll horizontally. And it's kind of, what is it, diminishing returns is what I'm looking for. And this is just how we might call this as a client. And I tend to think that this kind of sucks. This is just a different version of that same slide. We're basically just using Dave Cheney's functional options. So we have this opt type, which is a function that operates on our service. So we can pass in various functions as options to the constructor, and that way we have short, clear names that that don't cause us to have multiple different constructors, each named the same thing. Similar, a few questions. How much clarity did we lose here? Is this less obvious? And I also just wanted to point out that when we use shorter names, it's a little bit easier to predict what other functions and methods might look like in the rest of the API. So yeah, long names can clarify intent. Short names can reduce horizontal scrolling and encourage predictable patterns. They both have advantages. And I think that this is a very good point to show that, like, this is the reason that we have this rule. The further from its declaration that a name is used, the more descriptive it must be. Else statements. This is something that I would have done in Python 8 years ago whenever I wrote Python. Mostly because I liked to have a single return at the end of the function. But part of the reason that this is not really great in Go is that we have the typed nil issue. That's what this bug is. The the error type that is returned might not necessarily be error, but it might still be nil, and that'll make the error variable non-nil. This is something that I think is more commonly seen in Go code. You tend to see people define a set of variables and then go into a loop and try to find values for those variables. And this is something where most of the time an experienced Go engineer will pull out this code, this for loop, into a separate function and then just return once they hit that value in the loop. But clearly not everyone does. So here is a little bit more what I expect to see from an experienced Go engineer. We're returning basically whenever we hit an error. We don't have any else statements. We basically, whenever we have branching logic, we end up returning and truncating that branch. And that kind of helps us forget that detail. So the advantages of else statements, they can ensure that all possible cases are handled. This is something that I kind of miss from functional languages, actually, is the union type, just because that can be handled at compile time. But and then avoiding early returns means no hidden returns. That's, as I mentioned from my Python days, I never really liked to hide when what I thought was hiding when I return by putting a return statement inside of some nested if statement inside of a for loop or something. Nowadays, I tend to think that that was because I was writing too long of functions, but so in Go, we tend to think that there are downsides to this. I lean towards increased indentation being one of the main ones. Anytime that we increase our scope, we kind of have to create new areas in our brain to remember that our scope has changed and that we have a different set of variables that will go away once we pop back out of that scope. And they force us to merge logic flows. Merging, like when we branch out into multiple branches and then have to merge back in, it creates a mess of issues in our ability to read the code and understand what's going to happen for various values. There's also the issue in Go that for some reason, if you perform a declaration in an if statement, you can use the values from that declaration in the else statements and in the else if statements. And you can also do declarations in else if statements, which is weird. Okay, so moving on to interface, we have slightly different interfaces in Go than in something like Java, for instance. And we have these rules. Interfaces generally belong in the package that uses values of the interface type, not the package that implements those values. This is from the code review comments, and the bigger the abstraction, the weaker, or the bigger the interface, the weaker the abstraction. This is from Rob Pike's talk, Proverbs, that's it. And I did want to mention there are notable exceptions here. A lot of very old packages, even in the core library, tend to force you to violate this rule. But we're going to talk about interfaces more like their duck types than like their interfaces in something like Java. Um, this is like we define a local type that is a duck, and we have the methods for a duck to walk and talk. Then our compiler will check when we compile our code to tell us whether or not the values being passed in are similar enough to a duck for our purposes. So usually when we write our code, we will take in this interface type, and we don't really care what the type actually is. Like, for all we care, it could be a human who's just walking and talking really weirdly, similar enough to a duck. But you'll see a lot of even open source packages that don't really follow this pattern. I'm sure that this will be familiar to some of you. And this is, I see this a lot, especially in Pivotal, when we had a lot of people coming from Java who were new to Go. They would immediately lean into something like this, where you have this global interface type that's exported, and then you have your implementation that's unexported. And it causes a lot of problems with readability, I think. First off, it's going to hide all of your Godot comments. It also makes it really, really hard to actually dig into the code and find where the implementation is. Like, Godot has this really nice feature where you can click on a piece of code and it'll just go directly to where that's implemented in the source code. And if they're following this pattern, it just doesn't go to the right place. Another big problem is we're going to have to actually go and read this other package just to understand what this code is doing. And yeah, we don't know why any of these types can do what they can do. And we don't know how we might implement our quack method. So I would argue that in Go, this is more like what we want our code, the rest of our code, to look like. We have our duck interface, we have a direction, and we have a migrate function which returns the pond that the ducks migrated to. So the big thing that made me want to do this talk is that whenever I talk to new people to Go about doing things this way, they always ask me why, and I never feel like I have satisfactory answers for them. Like, I can send them links to Effective Go and to Dave Cheney's Go Proverbs talk and to the code review comments, but we never really delved into, none of those really delved into a ton of detail about why we want to go that route. And I think I might have figured out at least some of it. So just kind of a review of the code that we've looked at. Here's our concise code. How well do you remember it? How hard is it for you to track through? Here's our little if-else stuff. There's branching here. I did want to point out branching is never the problem. How often do you need to mentally merge? That's far more often the problem, at least with me, because I have to merge two separate models of what's happening in the code into uh, one kind of concept to hold in my memory. And I like storing all of that information twice is really hard on my short-term memory, and I don't have very good memory to start with. And yeah, that's how many branches of logic are you keeping in mind? This one is, I think, the most important point. How many imports do we need here? And how many other packages do we need to read before we can understand it? All of these types are local, so we really just don't need to dig into any dependencies here. So my statement for why is we're going to be talking a little bit about the mental stack. When I was talking with the VP at Pivotal, we were specifically talking about else statements, and he was coming from the Java world. And he still said using else statements is really, really bad. And he explained that your memory, your short-term memory, if you think of it like a stack, when you have to add a whole bunch of different branches onto that stack and then merge them back into the main logic, you're merging all kinds of scope, and it's really, really hard on your memory, and it can push a lot of the detail that you need to know to implement your new code or search for bugs or anything like that into gray areas where you kind of start to forget things. So I tend to think of Go's form of readability as making it easier for us to track code in our brain, in our memory, whatever. This is what I was talking about with the Pivotal executive. When we break context off of our mental stack, we're making room for extra information, and that's always a great thing. Removing these if else chains ensures that we only need to keep one logic branch in mind at a time, because we're never merging. We're basically creating these truncated branches, at least in the local function. Returning in our logic branches avoids, yeah, I just said that. Short names takes less effort to recall. It also means that when we're reading through code, things can be a little bit more predictable, so we don't need to remember, we can usually guess. Lower indentation directly relates to keeping less things in your mind. The more levels of scope that we need to keep in our brains, the harder it is to keep track of which variables are related to which scope. And small local interfaces reduce the number of methods we need to worry about in our dependencies. In those cases where you have a big interface type that everything imports, every implementation that is importing that interface type needs to know about every single method on that interface type. And that's not exactly ideal for our short-term memory. So my statement is that all of this makes it easier to predict code. What will happen, what the rest of the code looks like, and how we might implement future features. So when I'm writing code, I try to ask myself these questions, and I'm trying to suggest that maybe we should all ask ourselves these questions too. How do my eyes track when I'm reading the code? When I have to scroll back and forth, looking for different functions and, jumping to definitions all over the place, that's never really ideal for readability. Do I ever need to check other files? That's dealing with understanding imports is a frustrating exercise. Like if I have to understand 20 different packages just to read the local code, I'm never going to remember what all of them do. How hard is it to track a single code path? Basically, if I'm looking for a bug and I know which value the code was called with, can I trace through very easily to figure out which branches are being chosen? And do I ever have to think about logic that isn't directly represented in the code? Like in a lot of else if statements and else statements, a complicated enough Boolean expression will force me to kind of mentally invert the Boolean expression when I get to my else if and combine it with the else if's Boolean expression. And you kind of get that a little bit with early returns, but I find it a lot easier with early returns to just think of it as I'm forgetting about that case entirely. It's been dealt with. I don't need to worry about it anymore. So I've just written down a few exercises for this predictability idea, right? Following the if else chain, I am asking myself, how do my eyes track? How many branches of information am I tracking? And can I see a bug? And this gets back into the typed nils again. There is definitely a bug in this code. I specifically, it will never return a nil error, but I find it hard to notice that on first glance. These are just my little notes. Like, it's easy enough to understand the if statement here. I am kind of inverting the Boolean expression from the if statement when I get to the else if. The extra declaration here in the else if is a little bit hard on my brain, but it's all right. Using it again in the else statement is awful. And I have a playground link for the bug just to show it off if we want to come back to it after I'm finished drying out my throat, or if people want to view it when I put up the slides. So yeah, this is just the fixed code. Same questions. Also, it's worth noting, we got rid of that bug implicitly. If we don't return the error when the error is nil, then we will always return nil for a nil error. And we won't have to deal with the weird details of typed nils. And then the same thing for the big Sentinel interface types, right? How do your eyes track? Can you tell me what the rest of the implementation looks like and what information are you missing? And I find this, like, I could certainly implement all of this, but I have to, like, my eyes do not track well. I'm not reading this in a way where I feel like I'm going to be comfortable implementing all of these methods. The first thing, obviously, I have to go and read the DB package. I need to understand what the DB type can do. Like, maybe it's an SQL database, but maybe it's not. I also have to read the user package to understand how I might save a user. And I have to read the blog package. So going back and rewriting this using small local interface types, if we ask ourselves the same questions, I find this much easier to do. I can track through this really well. I can guess at what the implementation is going to look like, and I don't really feel like I'm missing much information here. We get immediately that it's a time series database. We know how to search for a email pattern using a provided compiled regex. We know how to store this data because it's all, we have all of this information locally. It's very easy for us to implement the rest of that code. And I did want to just jump into the exceptions that I mentioned earlier. Being a maintainer of GORP, I've had to deal with the Go SQL package a lot, and I hate it. And so the thing to notice here is, yeah, we can define our interface type, but in order for the methods on the interface type to match, we have to return pointers to sql.rows and sql.row. Because they're concrete types, we are going to have to implement, or we can't do our own implementation of them. We are going to have to instantiate them from the package directly. And if I'm not going to go to that package because I am really happy that Zoom isn't freaking out yet about my tiling window manager. But the SQL package, if you go and look at the sql.rows and sql.row types, all of their fields are unexported. So there is no way for us to create an actual pointer to an sql.rows. And like I mentioned earlier, this isn't super common. It happens. It happens a lot in older Go libraries. More modern packages usually don't do this type of stuff. But we can kind of handle it. If we are okay with making our own wrapper struct to wrap up the SQL DB, then we can make our own rows interface that we return. And because the SQL.rows type already implements all of these methods, we can just call db.query directly. We don't need to do any like translation between types, which is nice. It's still awful, but at least until Go starts, I don't know, recursively figuring out interface implementation as well as implicitly, we can't really do anything else about it. Anyway, that has been my talk about readability. Any questions or comments or anything?
Can you show the playground?
Yeah, I can jump over to the playground link and hope that Zoom doesn't freak out. Okay. Come on, go out as full screen. There we go. Yeah, so this is, I had to implement the rest of that, but validate user and validate password are, or well, I think I only had validate user on the slide, but it's the same type of thing. We're checking to see if v.err has bad characters, otherwise we're going to return v.err or v-error. You can see that it should return nil because we're passing in a valid ID and a valid password according to our logic here. But when we run it, we get error validating user. And that is because even though varr is nil, or has a value of nil, it does not have a type of nil, because validate password is returning a custom error type. And in this code, error is an interface. Well, I mean, we're returning an interface. So it doesn't really matter. If we're returning any value that has a type, it's going to be non-nil when we directly compare. This is also something I did a lot of work on Testify when I was first starting to use Go. And this came up there too, because in test libraries, oftentimes you'll use reflection to figure out if a value is nil or not. And that can cause a lot of problems, because with reflection, you can check to see if the value is nil separately from checking if the type is nil. And most assertion libraries do actually check only that. So if you have this case in your code, your production code is going to think that the error is non-nil, but your test code is going to think that the error is nil.
That makes sense. What do you see as the most common error, Sam? Or the most common, I should say, mistake according to these principles that you run into?
I would say definitely the big source of truth interface type. That, I mean, it's all over the place. It's in a lot of the big libraries that we use every day that are super useful. But like when you go to the Godoc documentation, all of the types that are being returned are these gigantic interfaces with no comments on them. And then when you go and actually get to the unexported implementation, it's got a whole bunch of really nice documentation comments that you can't even see in Godoc. I see a lot of the other problems in a lot of code that I run into. Heavy use of else if and else statements is really common in a lot of the code that I deal with when I'm first coming into a company. But I don't think of that as quite as big of a deal as the big, massive source of truth interface types.
You know, I really liked the comment that you made around looking around, searching through different packages and how they're all imported together. I feel like I've done that many times with the Go standard library. I've had to look at so many different packages and figure out how the heck all these imports actually construct the logic to make this thing run. I don't know if you've run into that too.
Oh yeah, and I mean, so I've written code that violates that principle pretty heavily. The editor that I wrote, I'm still trying to decouple from the UI library that I used, GXUI, because GXUI is no longer under development, and I've had to maintain a fork of it for years. And now there's there was a point where I wanted to try Shiny. There's I think Fine and GIO, and I want to try all of these UI libraries, but I've written myself into a corner because I'm just importing the UI library directly in all of my types and then extending those types, rather than making my own local interface types that define what I need from a UI library, and passing in the types from the UI library. If I had done it that way, I mean, my editor can pull in libraries dynamically at runtime. It's using the plugin package from Go 1.8. And I could actually implement a wrapper around a UI library and make it a plugin so that I could dynamically load a UI library into Vidar and mess around with it. And if I started liking it, maybe move that into a core package that's just built in.
Yeah, that makes sense. So there's always some level of main logic, right? And we're looking at func main here. But if you go to a package, your package is going to have some main logic, or somewhere you're importing something that's going to eventually have some main logic. It may not be called main, but it's usually somewhere. And if I remember, in one of your slides, you had scrolling what, top to bottom and left to right. Does that mean you put that main source of logic at the top of the page or the bottom of the page?
Usually I would put, I typically call that glue code. Usually I would put that at the bottom. A, it's probably not very important, and B, nothing else is going to be calling it. So you don't want to read that first because that depends on everything else in the code, right? When I write code, I try to keep it so that if I'm just reading from top to bottom, I have all of the information that I need by the time I get to something that I'm reading. And like, there's exceptions to that, of course. Sometimes it's just blatantly obvious and you don't really need to put a function called like convert user ID or something like that at the top of the file. Sometimes that stuff belongs hiding in either the bottom of the file or a separate file entirely. But that's how I like to write it anyway.
Cool. Well, I'll stop hogging Sam all to myself. Do we have other questions for the audience? All right. Well, if that's it, I'm going to hit the stop recording button.